All right, let's dive into one of the most wonderfully absurd hypothetical questions I think I've ever heard, all thanks to a brilliant short from Zach D. Films.
Yeah, you heard me right. Forget about checking their social media. We're talking about going full astronaut here. Is it actually possible to use, the pinnacle of human achievement in orbit just to see what a former flame is up to? Well, let's find out.
So just picture it. You're up there, floating around in zero-G, looking down at that big, beautiful blue marble. You've got access to some of the most insane technology ever built. And then the thought just pops into your head. I wonder what they're doing right now.
To answer this, we've got to break down the problems. And trust me, there are a few. Our very first massive hurdle, the sheer, absolutely mind-boggling distance. Okay, so let's put this into perspective. A really good telescope, right? It can give you clear details from maybe a mile away. But the ISS isn't a mile away. It's orbiting a staggering 250 miles above the Earth. Your standard issue telescope, yeah, that is not going to cut it. Not even close.
So obviously, you'd need a bit of an equipment upgrade. And when I say upgrade, I mean you'd need something just ridiculously, comically massive. A telescope truly built for a giant.
To get the kind of detail you'd need to actually spot a person from 250 miles up in the sky, you'd have to bolt a telescope onto the side of the station that's the size of, well, let's just say it's big, really big.
2. Football fields. Can you even imagine that? Trying to attach an optical instrument longer than 2 stadiums to the side of the ISS. It's completely absurd. But hey, for the sake of our little experiment here, let's just pretend you somehow managed it.
So you've got your gigantic 2-football field-long telescope attached to the station. Problem solved, right? Wrong. Not even close. You've just smashed right into an even bigger problem: speed.
Because now we have to talk about motion. More specifically, the massive, massive difference in speed between the space station and the planet it's flying over.
And this really shows you the problem perfectly. So the Earth spins, sure, but the International Space Station is absolutely screaming through orbit at over 17,000 miles per hour. That's more than 16 times faster than the Earth is rotating below it.
So, what does this actually mean? It means even with your giant, fancy telescope, you can't focus on anything. Your target city, let alone your actual target, would just flash through your viewfinder in a split second. It'd be like trying to read a license plate on a bullet train as it screams past you. It's impossible.
Okay, so this is where a clever, if slightly unhinged plan comes to mind. You realize the speed is the problem, so simple, just slow the station down. Fire up the thrusters, hit the brakes, and get it to match Earth's rotation perfectly. Then you'll just hover over your target. It's genius. Or is it? Unfortunately, this is the exact moment our brilliant plan slams headfirst into a little something called the laws of physics. And trust me, those laws are about to turn our little spying mission into an absolute catastrophe.
See, here's the crucial thing you got to understand. Orbital velocity. Think of it like this. An orbit is basically just continuously falling toward Earth, but you're moving sideways so incredibly fast that you keep missing it. So what happens when you slow that sideways motion way down? Well, you stop missing.
The instant you slow the ISS down to match the speed of the Earth's rotation, it is just not moving fast enough to stay in orbit anymore. Gravity, which has been pulling on it the whole time, finally wins that cosmic tug-of-war. The station would get pulled down, and pulled down hard.
And there would be absolutely nothing you could do to stop it. The source material puts it perfectly. Even with the station's thrusters firing at full maximum power, it wouldn't even come close to being enough to fight the immense pull of Earth's gravity.
The end would be swift, and it would be dramatic. The entire station, your giant telescope included, would just plummet straight into the atmosphere. The friction would cause it to get super hot and start to break apart, sending this shower of fiery debris raining down through the clouds before what's left of it all crashes into the ocean.
So, to recap our little thought experiment here, not only can you not spy on your ex from space, but in trying to do so, you would have single-handedly destroyed the multi-billion-dollar International Space Station in a spectacular, physics-induced fireball.
Which really just leaves us with one final thought, right? I mean, given the catastrophic failure, the immense cost, the violation of who knows how many international treaties, maybe, just maybe, there's an easier way to handle a breakout.